Hello children, today we are going to learn about the sign convention in the case of the mirror. Quite interesting and very important. न्यूमेरिकल सही सही करना है ना तो साइन कन्वेंशन के बारे में एकदम बढ़िया से जानना जरूरी होता है. तो देर किस बात की, चलो सीखते हैं. The Cartesian sign conventions. It was given by Sir Descartes. Okay, so you are very well aware of this graph paper and the positive and the negative x-axis as well as the y-axis, right? Using this, you are going to learn about the sign convention in the case of the mirror, right? How to do it? Let's start. So for this, you're going to draw a graph. X-axis, y-axis. 1, 2, 3, 4, 5 on the plus side of the x-axis. -1, -2, -3, -4, -5 on the negative x-axis. And the same on the y-axis also, the positive and the negative sign. Okay, now where are you going to place the mirror? You have got the origin, the red spot. Okay, there is a concave mirror which is placed centered at the origin. The pole should coincide with the origin, right? Okay, now I'm going to consider 2 points F2 and 2 times of F2 behind the mirror, and I'm going to consider F1 and 2F1 in front of the mirror, and I'm going to draw this again, right? So how do you take the positive and the negative side? There are certain rules for it. Keep the object between F1 and 2F1, and that is the object. Where should be the object kept in front of the mirror? It should be kept always in the left of the mirror. Right? Why? Because the image of the object should be seen on the mirror. Na? If you keep it at the other side, no image will be formed. That is the reason. Okay, now the image may be formed on the same side, it may be on the different side, whatever it is. Okay, now let's talk about the optical center. All distances should be measured from the optical center only. That means the distances, this is the optical center, the distance should be measured from the optical center only, not any other place. The distance to the right of the origin are positive, and the distances to the left of the origin are negative. Right? Okay, the distances measured perpendicular to the principal axis are taken to be positive, and the distances measured perpendicular below the principal axis are taken to be negative. Okay? Now, the distances rule is to be measuring all the distances from the origin only, that is the pole of the mirror. Right? Now, what about the focal lengths? Okay, now if you talk about the focal length of a concave mirror, it's always to be taken as negative, because I said the distance should be measured from the pole, and this is the negative distance, right? So if you are measuring this distance, the focal length of a concave mirror is negative, right? And that of a convex mirror, it is to be taken. See, if this is the convex mirror, you will have the reflecting side on the other side. Like, see, this is the reflecting side. This mirror is not drawn properly. Now, you should have the reflecting side on this portion. And if you get the rays which are parallel to the principal axis coming and hitting the mirror, the focus should be measured on the side of the positive direction. So for a convex mirror, the focal length is always positive. Is it clear? Okay, now let's do the mirror formula. What is the mirror formula? Mirror formula, you have something called as V, U and F. Now V is the image distance, U is the object distance, and F is the focal length. Image distance means it is the distance from the pole to the image. Object distance means from pole to object, and focal length means pole to the focus. That is called as the focal length. Okay, now talking about the mirror image, the mirror formula, 1 by V plus 1 by U will be equal to 1 upon F. Right? Now, you can use this formula to do all kinds of the numericals related to the mirror. Okay. Now, you also have the magnifications, and let me be specific. This is called as the linear magnification सिर्फ length बढ़ती है. So this is called as the linear magnification, and this is equal to the size of the image, that is h2, divided by the size of the object, that is h1. Right? Now, talking about this m, that is h2 by h1, or we can also put this as the negative part, because see, if there is two cases, m can be positive or m can be negative. If m is coming to be the positive value, that means the image is virtual, and if the magnification is negative, the image is real. Okay, now using the mirror formula and the formula for the magnifications, we are going to do some of the numericals. Okay, the questions of type A, problems which is based on the formula 1 upon V plus 1 upon U is equal to 1 upon F. Always remember, U is always to be taken as negative. F, that is the focal length of a convex mirror, is to be taken as positive, and the focal length of a concave mirror, it is to be taken as negative. This is the points to remember. Okay, now the first question comes on the board. If an object is placed at a distance of 36 centimeters from a concave mirror of the focal length 12 centimeter, find the image distance. So what is given to you? So let us draw a rough diagram. We have got a concave mirror, focus and a center of curvature. The focal length is 12, and where is the object kept? It is kept at 36 centimeters. That means the focal length, I know it is equal to 12, and the object distance is equal to 36 centimeter. Right. Now, the focal length, you can see it is 12, and the image is formed where? I don't know. I have to calculate that. Right. So, object distance U, it is equal to minus 36 centimeters. Why minus? Because the distance are to be measured from the pole to the object, which is 36 opposite direction. That means whatever is the direction of the ray, uske ulta hum le rahe hain. So it is minus 36. Okay. The focal length, it is a concave mirror. So the focal length is equal to minus 12. To find what? The image distance V. Okay. What is the formula I'm going to apply? It is the mirror formula. Putting in the mirror formula, 1 by V plus 1 by U is equal to 1 by F, or 1 by V is to be calculated. So it is 1 by F minus 1 by U, 1 upon minus 12 minus 1 upon minus 36. All that you have to do is substitute the values and get the answer. It's minus 1 by 12 plus 1 by 36. Now that is LCM is 36. So it's minus 3 plus 1. So it is minus 2 by 36, or that is equal to minus 1 upon 18. So what is the value of V? V is equal to minus 18 centimeter. Right? This is your answer. Though the image is formed at 18 centimeter in front of द मिरर. देखो नेगेटिव आ रहा है तो रियल होगा. हाँ, इसको कैसे पता करेंगे? आप मैग्निफिकेशन निकाल लो. अगर मांगा गया, इस प्रॉब्लम में नहीं मांगा है, सो इट इज माइनस वी बाई यू. व्हाट इज इट? माइनस V is minus 18 divided by U. U कितना था? It is minus 36. So the value is 18 by minus 36, which is equal to minus 1 by 2. So it is half the size, right? So यहाँ पर आपको उल्टा दिया हुआ है. Actually image की size object की size से छोटी बन रही है. ठीक है? Okay. Now let's go and do the next question. Second question. What distance from the concave mirror of focal length 10 centimeter should an object be placed so that the image is formed 20 centimeters behind the mirror? What's given to you? It's given that there is a concave mirror. The focal length is of 10 centimeter. Now, where should be the object placed so that the image is formed 20 centimeter behind the mirror? मतलब image आपको पीछे चाहिए और कहाँ चाहिए? पोल से 20 centimeters की तरफ चाहिए. So, what is given to you? फटाफट उसे लिख लेते हैं. Right? So, the first thing is focal length minus 10 centimeter. What about the image distance? See, the image distance, I'm going to take it as positive. Why? Because if it is the focal length is measured in the negative direction, so it is negative. Concave mirror hai. And what about the image distance? The distance is measured in the positive direction, so it is plus 20 centimeter. So this is the value of V. You are supposed to find out the object distance U, right? Now what you have to do? You have to put it in the formula and get the answer. How to do it? Let's do it. So what is the formula? The mirror formula is 1 by F is equal to 1 by V plus 1 by U. Now substitute all the values, whatever you know, and get the answer. निकालना क्या है भाई? 1 upon U निकालना है. So 1 upon U is equal to 1 upon F minus 1 upon V. That is equal to 1 upon minus 10 minus 1 upon plus 20. So what is the value? The LCM is 20. So it's minus 2 minus 1. So that is equal to minus 3 by 20, or U is equal to minus 20 divided by 3. So what is the answer? Minus 6.66. Tick, or approximately we can write minus 6.67 centimeters from the mirror. This is the distance, that is PB, that is the object distance, that is minus 6.67 centimeter in front of the mirror. This is your answer. ठीक है? Okay, बढ़िया. Third question आ गया भाई. An object is placed 20 centimeter in front of a convex mirror. It is found to have image 15 centimeters behind the mirror. Find the focal length of the mirror. What does it give it? Convex mirror. Convex mirror means the object should be placed here ना. ठीक है? इसका focus भी है और आपका center of curvature भी दिया हुआ है. Object is placed 20 centimeters in front of the mirror, and where is the image formed? And you're getting what type of the image? It will be virtual. Why? Because convex में हमेशा virtual form होता है. So चलिए अपन देखते हैं कितना होता है. So you have got to write the data. क्या क्या दिया है? Object distance U, that is equal to minus 20 centimeters. What about the image distance? Image distance is equal to, it is plus 15 centimeters. So V is equal to plus 15 centimeter. What are you supposed to find out? You're supposed to find out the focal length. My focal length कितना होगा, है ना? तो इसके लिए क्या करना है हमें? फॉर्मूला में डालना है. So what is the formula used? Mirror formula. So what is mirror formula? We all know 1 upon F is equal to 1 upon V plus 1 upon U. So it is 1 upon V. V is equal to 1 upon plus 15 plus 1 upon minus 20. So you have got 1 upon 15 minus 1 upon 20. The LCM, I know it is equal to 60. It is 4 minus 3, which is equal to 1 upon 60. So we have got the value of F is equal to 60 centimeter, positive 60 centimeters, right? So we will write the focal length of convex mirror is 60 centimeter, which is our answer. Got this, right? Okay. An image is formed 5 centimeter behind a convex mirror of focal length 10 centimeters. Okay, let's talk about it. I've got a convex mirror. Convex mirror के पीछे 5 centimeter पर image बन रहा है, and the focal length is of 10 centimeter. Where is the object placed? Object को कहाँ रखा गया है? ये पूछा जा रहा है. So let's write down what is the image distance. The image distance is equal to, that is plus 5 centimeter. And what about the focal length? The focal length here, it is also positive, so that is equal to plus 10 centimeters. And where is the object placed? So you are supposed to find out the object distance. Now where is the object? Object is placed, I don't know. So I'll just put a question mark. Now using the mirror formula, we have 1 by f is equal to 1 by v plus 1 by u. Put the values. What are you supposed to find out? U, na? So 1 upon u is equal to 1 upon f minus 1 upon v. 1 upon f, f is positive. That is how much? The focal length is given as 10 centimeters. So put 10 here. Minus 1 upon image distance, that is 5. So the LCM, I know it is equal to 10. So 1 minus 2. So it is minus 1 by 10. So the object distance is given as minus 10 centimeter. The object is placed 10 centimeter in front of mirror. To be specific, it is the convex mirror, which is our answer. Got this? Okay. Fifth question now. An object is placed at a distance of 10 centimeters from a convex mirror, focal length 15. Find the position and the nature of the image. Okay. Now you got this. There is a convex mirror. Focal length is equal to how much? The focal length is equal to 15 centimeters. Object is placed 10 centimeters in front of the mirror. You are supposed to find out the nature of the image and also the position of the image. Kahan aur kaise ban raha hai? So write down what is given to you. The object distance is given as how much? Minus 10 centimeters. The focal length, that is equal to f, and I'll put this as plus 15 centimeters. And what about the other things? That is your find out. To find the image distance and nature of image. ये दो चीज आपको निकालनी है. ठीक है. So what is the formula used? The mirror formula. We know it is 1 by f is equal to 1 by v plus 1 by u. You are supposed to find out the image distance. So 1 by v will become 1 by f minus 1 by u. Substitute the values. You'll get 1 upon plus 15 minus of 1 upon 10. So this becomes 1 upon 15 plus 1 upon 10. The LCM, I know it is 30. So it is 2 plus 3. So it is 5 upon 30. So it becomes 1 by 6. So V is equal to plus 6 centimeters. The image is formed 6 centimeter behind the mirror. Okay. Done. And then we have to talk about the nature. So what is the magnification? It is minus V by U. Put the value minus of plus 6 divided by U. Where is U? U is equal to minus 10 centimeter. So it's minus 10. So it is equal to minus of minus, which is plus. So it becomes 3 by 5. Since the magnification is positive, therefore the image is virtual. So what should be the answer? You have to write it this way. Image is virtual and formed 6 centimeter behind the mirror. This is the way how you calculate the answers. Right? Done. Thank you, bacho. We have done some of the numericals. You're going to go home. Now pick up your textbook, reference book, and do lots of problem which is based on the mirror formula. Right? करोगे ना? मुझे पता है करोगे. करो. Thank you so much.